So hi everyone, in this video, I am going to discuss fragmentation. So fragmentation is one of the issues with the memory allocation algorithms that we have discussed so far, and these are the fixed as well as the dynamic allocation algorithms. So what is fragmentation? So fragmentation actually has two types, the internal and the external fragmentation. And these are two types of memory wastage that can occur in memory management systems. So here's a brief explanation of each. So don't worry, I'll be giving an example for these two. So for the external fragmentation, so these are the unused spaces that are left between the fragments of non-contiguous memory. So these unused spaces are too small to help a process. So this occurs when free memory blocks are scattered throughout the memory space, making it challenging to allocate contiguous blocks of memory. Okay, so this arises from the dynamic allocation and the allocation of memory blocks over time, leaving small non-contiguous gaps of free memory. Okay, so the internal fragmentation, on the other hand, occurs when the allocated memory block is larger than what the process actually requires. So as a result, the allocated block contains unused or wasted memory space. Okay, so let us have an example. So fixed partition is an example of memory partitioning that could lead to internal fragmentation. So I have already given you the explanation of fixed partition in the previous video, so you can just go back to that. Okay, so assuming that we have this four processes, P1, P2, P3, and then P4 in this order of arrival, also P1 to P4, with this specific sizes 200K, 50K, 20K to 50K. And we are going to be allocating them in this memory with these four partitions. Okay, so let's say P1 is of size 200K. So we can put it in this partition 4. And then P2 of size 50K can be put in here in partition 3. And as you can see, in the fixed partition, we have mentioned before that a certain process occupies the whole memory. So in this case, what was allocated for P2 was the whole 100K when P2 only needs 50K. So what happens is there is an internal fragmentation. So we have a wasted memory of 50K. So since this P2 occupies this whole partition, no other process can use it. So again, the internal fragmentation is the difference between the memory allocated, which in this case is 100K, and the memory space required by a process, which is 50K. So in this case, we only take the difference and we have a wasted memory of 50K. Okay, and then for P2 on the other hand, P3 on the other hand, it has a size 20K and it can only fit here in partition 2. So again, this whole partition will be allotted for P3. So in this case, P3 has been given the whole 100K when it only needs 20K. So there will be a wasted memory of 80K. So again, the internal fragmentation is the difference between the allocated memory, which is 100K, minus the memory space required by a process, which is only 20K. Okay? So same for P4. So P4 is also allocated with 300K when it also needs 250K. So there are a lot of wasted spaces, and this leads to internal fragmentation, or the wastage of memory within a particular block or partition allocated to a certain process. All right. So now the problem of internal fragmentation can be reduced somehow by effectively assigning the smallest partition, but large enough for the process. And does it sound familiar to you? Yes, it is the BestFit algorithm. So The BestFit algorithm is one of the dynamic partitioning memory allocation algorithm, and it can be a solution to lessen internal fragmentation. But the problem is it can also lead to external fragmentation. So this is the definition of the BestFit algorithm. So we are actually assigning the smallest partition but large enough for the process. Okay, so if you want to know more about BestFit algorithm, kindly see the previous video that I have uploaded. Okay, so for external na fragmentation, so this occurs when the free memory blocks are scattered throughout the memory space. So these are the unused spaces that are left between the fragments or non-contiguous na memory. So these unused spaces are too small to help a new process or to accommodate a new process. So we still have the same batch of processes here, except that we have added P5 of size 350K. Okay, so we still have the same partition 1, 2, 3, 4, and then 5 with this sizes 100K, 500K, 200K, 300K, 600K. So let us try to use the BestFit algorithm in this. So again, in the BestFit algorithm is we are going to look for the smallest na partition that can fit a certain process. So in this case, the P1 of size 212K can fit where? Can fit in partition 4. Okay. Now we have left 88K, and then P2 of size 417K may fit on partition 2. Again, the process would be like to look for the ascending order of the sizes of the holes. So partition 1 followed by partition 3. Partition 4 followed by partition 1, then followed by partition 3, then followed by partition 2, which has 500K. So this fits P2. Okay, and then next P3 of size 112K. What is the smallest na block again that can fit P3? So that would be in partition 3. And then size P4 of size 426K can fit in partition 5. So I'm not explaining the BestFit anymore because I have a specific video for this. Okay, so now we have a P5 of size 350K. So where else can we put it here? So the available na holes are partition 1 of size 100K, partition 2 of size 83K, partition 3 of size 88K, partition 4, 88K also, partition 5, 174K. None of this is enough to cater P5 of size 350K. But if we look at this small non-contiguous blocks of memory, this all sums up to 359K. So all of 4, partition 1, 2, 3, and then 4, sum up to 359K. But these are unusable since the holes or the memory chunks are not contiguous. So P5 could have fit if it's only clumped sila kumbaga, or they are in a contiguous na order. Okay, so that's the example of the external na fragmentation, wherein the free na memory blocks are scattered. So the free memory blocks are here, and then here, and then here, and then here. So if only they are contiguous, they could have been useful. All right, so that's all. In the next video, we are going to discuss about the segmentation.